Hey guys, welcome to a new video. In this video here, we're going to cover a ton. We're going to convert a YOLO-NAS model to TensorRT. We're going to take every single element from going from a PyTorch model. We're going to load in a pre-trained model. I'm going to show you all of that. And then we're going to see how fast we can actually run these models when we optimize them to run on GPUs, on specific hardware. So we're going to cover each element in the whole pipeline for converting a YOLO-NAS model to TensorRT. And we're also going to run it with ONNX. So you can both run it on CPU, GPU, and you're going to see some awesome results. These models here can run very fast and up to 100 frames per second. So we should definitely, before we deploy models, optimize them, and it's actually really hard to do. I'm going to cover all of it in this video, so definitely stay tuned for that. So first of all here, let's start inside the SuperGradients GitHub repository from Daisy AI. These are the creators behind YOLO-NAS, and this is the model that we're going to use. We're going to set it up. We're going to see some results to start with. We're going to export it to ONNX, convert it to TensorRT, and then we're going to see some astounding results. So here is basically just the GitHub repository. If we just scroll a bit further down, we can see the different kind of like computer vision tasks that it can be used for, and also some benchmarks. So here we can see that they both have this quantized model, which is actually like pretty awesome as well. You can also do that in the different steps for converting it to ONNX and also TensorRT. So you can basically just convert it from float 32 to int 8, and it will significantly speed up your models, as you can see down here. So we can see the latency down at the bottom, so it's a millisecond. So if we're actually like optimizing these models, we can run down to 5 milliseconds per image. So that is actually like pretty fast, and up to 200 frames per second on specific hardware. So these models here are really cool, and you should definitely optimize them because the PyTorch versions are just very slow. So let's cover that in this video here. First of all, we're just going to get like a pre-trained model. Let's see some inference results in pre-trained model, and let's start with the whole pipeline. So let's now just go inside YOLO-NAS, and let's go inside the documentation. So we will have the documentation up here. Then if we go inside the sources, we can basically just see all the different kind of examples that they have. Let's scroll down to the export. So first of all, we just scroll further down. So here we see model export. So let's go into that one and basically just go through it step by step. So here we can see that we can both enable floating point 16-bit and 8-bit quantization, and we can export the model for ONNX and also TensorRT. And if you just scroll a bit further down, we can see like how we can pip install it, set it up, and so on. How we can actually like get a specific model here. So we can use pre-trained models, but you can also use your own custom trained models, and I'm going to show you how you can use that. So if you just scroll a bit further down, we're basically just going to create a notebook with all of this. I've cleaned everything up for you, and it will be available in the video description. Then we have two different output formats. So here we're basically just going to focus on the flat format because we just want to process one image. Let's say that we have a video stream, just load in one image from the video stream, we process it, and then we just keep doing that for our video stream or our camera. And we can also run it in batch mode if you have multiple batches and multiple images that we want to process at the same time. So we're going to use this flat format where we have the batch index, so that will basically just be a 1. Then we have our bounding box, class score, and also our class index. If we scroll a bit further down, we can then see how we can visualize the prediction. I'm going to cover all of that in the code where we're actually going to see the results as well. But the last thing here that I want to show you guys is down here at the bottom. So it is basically just for choosing the backend for exporting the model. So we can see that the support backend is ONNX runtime and also TensorRT. I'm going to show you how we can export it in both formats. I'm also going to show you how we can set it up with TensorRT, run it both with ONNX, TensorRT, and then we're going to see how fast it really is and also see some results. So you guys, after this video here, if you follow step by step, you will be able to convert your models, your PyTorch model with the YOLO-NAS pre-trained models and also your custom models into ONNX, TensorRT, optimized for running on hardware to get real-time performance. So let's not just jump into this Jupyter notebook. I've created a Jupyter notebook where we have the examples cleaned up from their GitHub repository. Then we're just going to go through it block by block. But first of all, make sure that you have Cuda installed on your computer and also TensorRT, because that is what we're going to use both for the backend, but also later on for converting the model. We're going to do some benchmarking with TensorRT. They have commands directly we can use in the terminal and also run inference directly in there. So we need those two different kind of things. So if you have Cuda installed already, you should probably have that. Then we only need to go in and install this TensorRT. They have a pretty good guide in here if you just choose the version that you want, and then you will also get the installation guide. Just open this one up here, follow it step by step. This is the best guide out there for actually like installing it. If you're on Windows, just scroll down here to the zip file. You just need to download a zip file. So you can set it up with your environment variables where you just specify the path to the DLL files, or you can copy those DLL files into your Cuda directory. So let's now jump back into the code here and let's see how we can set it up. So first of all here, let's go in and get a model. So models.get, we can get this YOLO-NAS large model. They have a large, medium, and small model. And here we're just going to use pre-trained weights. We're going to use the Cocoa pre-trained weights. Up here at the top, we just have some different modules that we actually need to import, both for our object names, training, and then we also need these conversions from super gradients. This is the detection output format mode because we want to have our flat mode. And if we also want to do quantization, we also have this export quantization mode and our export target backend. So we can choose between ONNX and also TensorRT for our backend export. So this is how you can get a pre-trained model, but you can also go down and use a custom trained model. I already have a video about that here on the channel, so definitely check that out. We take a whole data set, we create the whole training pipeline, setting up the model, labeling the data set, exporting data set, training the model, exporting the model, and then you can basically just specify the path here to the average model and also the base model that you use. So if you have trained it on a YOLO-NAS large model, you just need to specify here the number of classes that you have trained and which is in your data set, and then specify the path here to the model that you have downloaded from your Google Colab notebook. Everything is available here on my YouTube channel, so definitely go check that out. So yeah, we have our pre-trained model. You can also have your own custom model. That's everything that we need. Then we can call export directly on our model. So here we basically just specify the name of the ONNX file that we want to export. So YOLO-NAS underscore pre-trained underscore large dot ONNX. We can set the confidence score threshold here. So let's just go with, for example, like 30% confidence. We can set the non-maximum suppression threshold. So it's also going to do non-maximum suppression. And that is why it's really good to use this export function from Super Gradient. It has taken care of everything from you. You don't have to do like the post-processing, the pre-processing. Everything is built into the ONNX model and the ONNX graph. And then you can actually like run that on the GPU as well. So if you're just having a standard ONNX model, you don't have anything, you just have a raw model, then if you want to apply non-maximum suppression after that model, then you can't really run in real time because we actually need to run our non-maximum suppression on the GPU. Let's say after we have done a forward pass of our image, then we probably have like hundreds, if not thousands of detections, and they're overlapping all over each other. So then we actually need to go in and use non-maximum suppression to reduce the bounding boxes to the specific objects that we have in our scene. So we're basically just choosing the bounding boxes that fits our objects the best. So we actually want to build a non-maximum suppression inside of our ONNX file as well. And Daisy with Super Gradients is taking care of all of that. We can also set the pre-non-maximum suppression detection. So basically like how many predictions we want to limit it to, and also the maximum number of predictions per image. So say that you only want to detect the best object in the image, you can just set it to 1. If you want to have like an arbitrary number of predictions, you can just set it to like a very large number. Let's just go with 50 in this example here, which is actually like just an arbitrary number. Then we need to specify our output prediction format. Right now we can set it to flat format. Again, we just go inside detection, output format mode, set it to flat format if you just want to process a single image with a batch size of 1. So we can really use dynamic batches when we're going to export it with ONNX, and also when we're going to use TensorRT, we need to specify explicitly the batch size. So that is very important. And if you're getting any errors, it is probably the reason because you're not using like explicit batch size or a batch size of 1. So definitely have that in mind when you're actually like going through your errors if you run into any. We can also set the engine down here, but I'm going to wait with that for just a second. So we can set it to TensorRT, and then it's going to export that as a TensorRT backend. But the reason why I don't want to do this to start with is that we can actually use the ONNX model together with TensorRT still. So we actually don't need to export a TensorRT. We can just use the ONNX model in TensorRT as well. But if we export it into TensorRT, we can use it in ONNX. So unless you have a really good reason for exporting it with TensorRT backend, just go with the ONNX model and you can use it for both. As you're going to see with ONNX, we also get very fast inference speed. So let's just run this and see some results. So it's just going to run here. We might get some outputs. Here we can see that it's downloading the pre-trained weights, successfully loaded the pre-trained weights with the architecture YOLO-NAS large. And now we have started the export. And now we can see that the export is done. Let's go over and see if we actually have this model file in our directory. So we should have it a bit further down here, YOLO-NAS pre-train underscore large dot ONNX. So now we have our export ONNX file here. Let's go back into our notebook. There we go. We have returning these export results. Let's just take a look at them, where we actually get a lot of information of how to use the model, the input shape, and so on. Here we can see that the input image type is unsigned integer 8, so this is actually like a quantized model. So here we have a batch size of 1 and 3 channels for our RGB image, and then we have 640 by 640 image. Then we can also go down and see we have these parameters that we set up when we initialize the model. Here and now we can see how we can run with ONNX, how can we load in the model, how can we do a forward pass with this inference session with ONNX runtime. If you want to run this, you can just pip install ONNX runtime, and if you want to use it on GPU, you just have ONNX runtime dash GPU, and then it will take care of all of it. Here we set up the Cuda executor provider and also the CPU, so it's going to choose whatever is available on your computer. Then we'll have our inputs and also our outputs that we can directly go in and extract. This is how we're going to get the extraction. So we have our predictions, which is the output from our model. Then we have our flat predictions, where we have our, first of all, we have our batch. We don't care about that. Then we have our bounding box, confidence, and class ID, where we're just having a for loop looping through all the predictions that we have from our model. Then we can use that in our own applications and projects, and I'm going to show you how we can do that in just a second. So here we also have a command with TensorRT. So once you have TensorRT installed, you can use this TRTX for executing like TensorRT models. You can do benchmarking, do average runs. You can also do conversions of models. So how can you convert an ONNX model to a TensorRT engine? And I'm going to show you all of that as well. But let's now just go down and run this model here and let's see an example. So we're just going to load in an image. We're going to resize the image to our input size, which our model takes. This is really important as well. All of these parameters here are fixed and it needs to be the exact same every time. Now we have our image. We can go down and create our ONNX runtime inference session. We specify the path to our model. Let's just go and take the correct one. So we're going to copy the relative path, throw it in here. Then we have that. We set up our Cuda parameters and our CPU parameters. We have our input, outputs, and then we're also going to time how long it takes to do inference with this session.run. And then we're going to print our inference speed and also the results. So we've set up the model, we've exported the model, loaded in an image, we set up the model, and now we're going to do inference. Let's hit Shift Enter, and it's going to run. So first of all, you just need to set up the runtime before it's actually going to do the forward path. So this might just take some time, and this is just initializing the model. So if you're running this in real time on a video stream, you'll set this up with outside of the for loop or a while loop. Now we can see that we get our results back. Time here, so around 12 milliseconds. So that's almost 100 frames per second directly with this large model here. If you're running the PyTorch version, you will probably only get like a few frames per second with the super gradients directly. So this is already like an increase by 5 to 10x. So this is very awesome. I'm running this on a 3070 graphic card, so it's not the best out there in the world, but we can see we get really good performance. We also get all the predictions out here. So again, those doesn't really make sense right now, but let's now go down and visualize our predictions. So I have our results. We can set them equal to our flat predictions and just extract the results as we saw in the exported results variable. So let's run this and take a look at it. So here we can see that we have class ID 0 and also 2. So this is probably like, this is person and this is probably like a car or something like that. But let's just take a look at that after. We have the confidence score and we have our bounding box. Then we can go down and use our predictions to just directly visualize them with super gradients. So let's just run this block of code and don't spend too much time on this. Let's call the function show predictions from flat format. There we go. Now we have our predictions. We have the persons walking here. So here we have like a bench, but again, it's very low confidence score. We have some cars in the background and we also have a person. So now we can see both the confidence score and also the predicted label together with the bounding boxes. And again, this is just a single image, but it only took 12 milliseconds to process this image. You can basically just extract this code here directly if you want to use the ONNX model out of the box. This is really fast. You're going to run very, very fast if you're running this on a live webcam or a video stream. The only thing that you need to do, just set it up. I have a bunch of code for that. Set up a video streamer with OpenCV. Initialize all the things outside the while loop. Then have the while loop and then basically just have the run command and also the visualizations, the for loops for running through the results, and then you're good to go. You have the whole pipeline up and running. You can process videos in real time now. So I promised you guys to go back to this command here again. Let's just go in and grab that, and let's go in and open an Anaconda prompt so we can basically just benchmark our model. So let's now go back here again. I just need to go inside the correct directory. So let's just delete this part. So first of all, I need to cd into the directory where we are. So cd YOLO-NAS from super gradients, and then we can call the command again. Now we need to specify the path to our model. So now we called it YOLO, YOLO-NAS pre-trained and large. Let's just verify that this is correct. So YOLO-NAS underscore pre-trained underscore large, unsigned integer 8, and then we want to run average run 100 and duration for 15. So it's not just run here, it will take some time, it will load in the model, and then it will do the benchmarking, and then we're going to see the results after that. Okay, so it's now done running, and we have these benchmarks. If we just scroll a bit further up, we can see that we have these average and 100 runs. So it's basically just going through 100 times on these examples. So it's loading in the ONNX model, converting it to TensorRT, and then it's running everything in here, doing these benchmarks. So here we see that we get around like 12 milliseconds, sometimes 11 milliseconds, but yeah, probably around average of 12 milliseconds. If we go down and see the latency, 10.5, maximum, the mean, and so on. So again, we can see the minimum is around 10 and the mean is around 12. So again, this is pretty fast as well, kind of similar to what we got for the ONNX model. So this is kind of like the same, but this is pretty cool. We can directly run it in here. We can benchmark it. We can see a lot of different kind of like metrics and also information about our GPU and the model. So this is how you can benchmark it. So let's now see how we can convert an ONNX model to TensorRT. First of all, we had the PyTorch model, converted that, we saw the results with ONNX, set it up with GPU and also CPU. Now we have the benchmark. Let's now take the ONNX model, convert it to TensorRT engine, and let's run some inference with that. I'm going to show you how we can process all of that, create the engine, take the engine and run inference with that and see the results. So now I have a command that I've just copy pasted in directly. We have TRT exec again. Now we need to set this explicit batch, as I mentioned in the start. Like, this is very important. Like, often when you're getting errors, it's because you don't have the correct dimensions, the correct values that you're actually converting your model with, and also you need to convert the model in the same versions of TensorRT, Cuda, and so on that you're going to run inference with. We also need to set this explicit batch because it can't do dynamic batching with the TensorRT. Now we need to specify the path to our ONNX model again, and where we actually want to save our engine. So right now, let's just go in here and we have YOLO-NAS underscore pre-trained again, underscore L. There we go. Now we also need to specify this argument save engine equal to TensorRT engine. First of all, I'm just going to copy paste this, and then I just want to show you guys what we can actually like do. So let's just run this here. It's going to run for some time, convert the model and so on. Until then, let's open up a new anaconda prompt and let's just call this TRT exec. So these are all different arguments that you can actually like throw into this. So you can set like the average run, percentile. You can set up different kind of like export outputs, devices. So if you have like multiple different CUDA devices, you can also set that up. If we scroll a bit further up here, we can see the warm up, iterations, which we've already been playing with. We can also set the batch. If you're using like batch format, you can also just set the batch equal to 1 or the explicit batch. If we scroll a bit further up, we can see we have load engine, save engine, which we're using now. So we have all these different kind of arguments. You can go in and see here how we can use them. Also, if you want to use like floating point 16, int 8, and so on, you can see how, and a short description over here to the right. So I just wanted to cover that while this is running. So now our model has been converted into our TensorRT engine, as we can see down here at the bottom. If you just scroll a bit further up, we can then see it does this benchmarking again, now on 10 runs. Again, we get around this 12 milliseconds. So if we go over here to the left, we can now see we have this YOLO underscore TRT dot engine. So this is the engine that we're going to use to actually like run with TensorRT. So we both have our ONNX model now and also our engine model. You can also have like a TRT model. It is basically the same as an engine model. So now to be able to run inference, we actually need to go inside this GitHub repository. We need to pull the code. So you can just go in and clone this repository into your current repository, or just go in and take the individual files. So if you just go inside this YOLO-NAS TensorRT, we need to go inside and use this infer underscore TRT. It's going to do a lot of different things in here in the backend as well. You just need to go in and change the max size, the model weights, also the names for your classes if you're using a custom model. But I've already done that. We have the repository in here. If I just scroll up here to the top, so we have YOLO-TensorRT. If we go inside of that, we have YOLO-NAS, but we also have all these other YOLO versions. This is the YOLO-NAS from SuperGradient and Daisy AI. So now we have these TRT backend and the TRT loader, which is the most important thing. We won't go into details, like this is very complex and you definitely have to like sit for a very long time to be able to understand all of this, but it's going to pull up these loaders. Then we can use this inference script here to directly use our model that we have. So if you just scroll up here, the only thing that I've changed is the max size and also the name. So these are just for my local path. Then it's going to do this detection. I've also removed some of this part here. So I'm just going to use OpenCV to load in the image. So it doesn't really like resize. It doesn't like rescale. I don't want to post-process my image. I just want to take the raw image, convert it to an RGB image so we can throw it through the model and get our results back. So this is everything. Again, all this code here will be available in the video description under. Then we just have this for loop again running through all our predictions. We're going to draw a rectangle and also put some text. This is just going to process a single image. We create an instance of our model. We specify the model weight. So this is the YOLO-TRT engine that we have just converted from our ONNX model with TRT exec. And now we just specify the path to a test image. So we just read an image with OpenCV. We do this detection function on our image with our TensorRT model. If you just take a look at this test image that we're going to run, I'll just scroll down. So this is just a selfie of me. We're going to take the image, convert it into the correct input format. So that's 640 by 640. Throw it through the model, and then we're going to see the results. So you can basically just wrap up the code so you can run it on live webcams, video streams, or whatever you want to run inference on, both with ONNX and TensorRT. So let's now go ahead and open up a new Anaconda prompt, or we can just use this one here. So like right now, let's go inside YOLO. So YOLO TensorRT, and now we need to go inside YOLO-NAS again. There we go. If we just go inside the directory, we can now see that we have our somewhere we should have our infer_trt.py. So let's just call Python infer TensorRT py. It's going to create an instance of a model, read an image, and do detection. And along the way, it's also going to write some of the results out to the directory. So let's now run the program, see the inference results with TensorRT. So first of all, here we can see that I'm just printing this TensorRT model object. We can see the input size, so 3 by 640 by 640. The profile shapes, it's going to divide it into each individual channel. And then we can see the binding shape and also the flat prediction binding shape. So this is the output where we get the badge, the bounding box, confidence score, and also the class. So this is for our explicit batch export. And then we can basically see that we did a forward pass, and now our Python script is actually done running, and we should be able to see our results. So again, I'm not directly displaying it, but if we go over here to the left, we can see the results and also our test. So this is the image that we're going to throw into the model. This is the post-processed image. This is the image that we throw into the model directly with TensorRT, the engine file that we did set up. And now we get the results. So this is the input, and this is the results with the TensorRT model. So we're detecting a person. We can see the class up here at the top, but we can also see the confidence score. So confidence score of 0.97. So 90% confident that this is actually like a person that is in this frame. And that is correct. And this is how we can run inference with both ONNX and also TensorRT. So this is actually like very complex. You guys might have to digest this for a bit. This is actually like a video covering a lot of stuff. So you probably also want to go back, watch this video here several times, try it out on your own, have it on the sideline, try to follow it along step by step and see if you can actually like do it on your own models or use some pre-trained models as I did in this video here. It's a really good thing to know when you're working as a machine learning engineer and specifically computer vision engineer, where we want to have our models run as fast as possible. Let's say that we want to create a real-time system. This can actually like have a huge impact. Let's say that we can go with a lower budget GPU compared to just buying like the most expensive GPU out there because we just want 100 frames per second. But we can actually like go with a decent GPU, just optimize our model for that specific hardware, and then we're both saving money, we're running faster, and we create some really cool projects and applications. So I hope you have both enjoyed this video here and also learned a tiny little bit. This is very hard to get into, so if you guys are a bit confused, it is a really hard topic to get into. You just need to put in the time. And then I'll just see you in one of the upcoming videos, guys. Until then, happy learning.